Here is a free response question for AP Calculus that includes concepts from Units 3, 4, and 5. Simply put, we're given a curve defined implicitly, and we're asked to answer 4 questions about it. So we'll dive right in. We'll move to a new slide, and we'll start with question A. I mentioned that we were given this curve, which is defined implicitly. 2x squared plus 3y squared minus 4y equals 36. And in letter A, we're asked to show that the derivative is 2y minus 2x over 3y minus 2x. We'll do a little implicit differentiation and we'll arrive at that result, unless I make a mistake. So the curve is 2x squared plus 3y squared minus 4xy. Make a note, that's a product, and then that equals 36. That's a constant. And then you know with implicit differentiation, you just start taking derivatives. So the derivative of 2x squared is just 4x. The derivative of 3y squared will be 6y, and then we have to multiply by dy over dx because of the chain rule. And then the tricky part comes in with this product. I'm going to... The way I see this product is negative 4x times y. So I'll run through the product rule, keeping that in mind. So the derivative of negative 4x is negative 4, and I'll multiply that by y. And then the derivative of y is dy over dx. I'll multiply that by negative 4x. And then the derivative of 36 is 0. Sometimes students just write 36 there, so just keep in mind that you take it slow and make sure you're doing all the derivative rules correctly. Okay, so we've got some like terms. I'm going to collect the dy over dx terms on the left. That would be 6y 6y dy dx minus 4x dy dx. And then I'll collect the non-dy dx terms on the right here. So I'm going to add 4y over and subtract 4x. I just happen to notice that all of these have a factor of 2 in there, so I'm just going to multiply the whole thing by 1/2 to reduce that down right now. This is 3y dy dx minus 2x dy dx equals 2y minus 2x. And you can see how we're really close to getting the result that we're looking for. I do not like the way that x turned out. Let me clean that up. Okay, we're going to factor out dy dx. That leaves 3y minus 2x. And last step is to divide by that factor, 3y minus 2x on both sides. And we've arrived at the intended result, which is that dy over dx equals 2y minus 2x over, I don't like that x again either, over 3y minus 2x. And thank goodness that is exactly what we were supposed to get. So I feel good about that answer. That's called implicit differentiation, and it's okay if your derivative is defined in terms of x and y. Just remember, it means if you're trying to compute the slope at a point, you need to have the x and the y values in order to get that. Okay, let's attack letter B on the next slide. Letter B says find the slope of the tangent to the curve at each point where x equals 6. At each point on the curve where x equals 6. And I just, on the last side, ended by saying that if you're going to use this formula to get the slope, you need to have the x and the y values. So here we're given the x value, and we have to see if there are one or more y values associated with that x value, and then find the slope at each of those points. So to get those y values, we're going to need to plug 6 into the original equation. So our function or our equation was 2x squared. I'm going to plug 6 in where the x is. I'll put my x in red there. 2x squared plus 3y squared. That is a y. Minus 4 times 6, because x is 6, times y equals 36. And now we'll clean this up a little bit. 36 times 2 is 72, plus 3y squared, minus, was this 24y, equals 36. And it looks like I can multiply each of these by 1/3 and reduce this down a little bit just to make my arithmetic easier. 72, what is 72 divided by 3? That must be 36, 12, 24. And this would be y squared, and this would be 8y, and this equals 12. And then, of course, we're going to have to solve this quadratic, so we get y squared minus 8y minus 12. So that's going to be plus 12 equals 0. Factoring this, what is this bad boy? It's minus 3, minus 6, and minus 2. That means the solutions are 2 and 6. Okay, we have two y values, so we have 2 points. We have 6, comma 2 and 6, comma 6 that we want to deal with. So let me start by working with 6, comma 2. At 6, comma 2, m, the slope, is going to be dy over dx with those two values plugged in. So that's going to be 2y, which is 2 times 2, minus 2x, which is 2 times 6, over 3y, so that's 3 times 2, minus 2 times 6. Oh, let's see if I'm any good at arithmetic here. That's going to be 4 minus 12, which is negative 8, over 6 minus 12, which is negative 6. So that's going to be 4/3. So one of my slopes is 4/3. Now let's think about the point 6, 6. Oops. The slope is going to be dy over dx with 6 and 6 plugged in. So 2 times 6 minus 2 times 6. Ooh, we get a 0 on top. So if we get some other value on the bottom, this thing's just 0. And it's going to be 3 times 6. So we're going to get 0 here. And I'll just leave that blue. What the heck? Nah. Let's clean that up. You deserve better. Okay, so let's make sure this is going to be 0 over, that's a 0, over, what is 18 minus 12, which is 6, so that's just 0. So the slope at 6, 6 is 0. All right, let me just double check and make sure we answered everything we're supposed to. Find the slope of the tangent line to the curve at each point where x equals 6. And sure enough, we have 2 points where x equals 6, and we have 2 slopes. 4/3 when the point is 6, 2, and 0 when the point is 6, 6. All right, we're done with this one. Let's attack letter C, on the next slide. So in letter C, we're asked to find the positive value of x, at which the curve has a vertical tangent line. Show the work that leads to your answer. Find the positive value of x where the curve has a vertical tangent. So remember, we typically see vertical tangents when the slope, when the slope is some number divided by 0. So we're looking for something like this. A number on top that's not 0 divided by 0. That's where we're going to see a vertical tangent. And we know that our derivative is 2y minus 2x over 3y minus 2x. So basically what we want to do is set this equal to 0, and that's what I'm going to do. So 3y minus 2x equals 0. And we are trying to find, remember, we're trying to find a positive x value. To find the positive x value, we'll need to plug something in for y to the original equation. So I'm going to solve this thing for y. When I solve this for y, I think you'll agree I get y equals 2/3. 2/3 x, excuse me. And so what we'll do is we'll take this 2/3 x, we'll plug it into this thing, and for y, and then we'll solve for x. So let's see if we can do that. So our equation is 2x squared plus 3y squared. So remember, we're plugging in 2/3 x for y, and we're going to square that thing. Minus 4 times x times 2/3 x. And this is just a lot of algebra, unfortunately. I know how much everybody loves algebra, though. Okay, let's solve for x and get this thing done here. 2x squared. This is going to be 4/9 x squared times 3. That'd be 4/3 x squared. Minus, this is going to be 8/3 x squared equals 36. And you know how I hate fractions, so I'm going to multiply everything by 3, but then I'm also going to reduce by 2 just because I notice everything's even. So let's multiply this by 3/2. It'll make my solving easier later. That makes 3x squared plus 2x squared. And then this is going to be minus 4x squared. Oh, that's convenient, because that just equals x squared. Now I just have to be careful here. 36 times 3/2, that's going to be 18 times 3 is 54. And so I end up with x squared equals 54. And we need to take the square root of 54. Normally there'd be 2 square roots, plus minus 50, square root of 54. But remember, we are asked just to find the positive value, so all I need is the square root of 54. And just to be thorough, that's 9 times 6, so the square root of 9 is square root of 6. So this is going to be 3 square root of 6 in the simplified radical form. So square root of 54, which is simplified to 3 square root of 6. That's the positive value of x. That's the x equals, where this curve has a vertical tangent line. All right, just double checking. It looks like we've got it. Let's wrap this thing up with letter D on the next slide. For part D, we let x and y be functions of time t that are related by the equation 2x squared plus 3y squared minus 4xy equals 36. Same equation we just worked with in the other parts. Notice these are functions related by this equation, so I'm guessing this is going to be related rates. At time t equals 1, the value of x is 2, the value of y is negative 2, and the value of dy over dt is 4. We're supposed to find the value of dx over dt at time t equals 1. So when we do related rates, we usually like to write down our information that we know. We're going to work with x equals 2, y equals negative 2, and dy over dt is 4. Now remember, we don't plug those in until after we do the derivative. The good news is that we already have our equation relating our quantities. So we're just going to write this thing down, and then we'll have to do the derivative implicitly. Everything is being with respect to t. Just don't forget that. We're taking the derivative with respect to t. And this is still a product here. Negative 4xy is still a product. Okay, so we start taking the derivative. This is going to be 4x dx dt due to the chain rule, plus 6y dy dt due to the chain rule. Remember, I'm treating this as a product, and I keep the negative 4x as one of my factors, and the y as my other factor. So this is going to be minus 4x dy dt and minus 4y dx dt. And the derivative of 36 is still 0. Still 0. Now we're going to plug in our values, and then we'll be done with this thing. 4 times 2, we do not know dx dt. I didn't write that at the beginning, but usually when you're doing your related rates, you want to make sure that you're writing down the thing you're trying to find, just to keep yourself organized, which was dx dt for us. Plus 6 times y, we know y is negative 2. That was supposed to be a 6. And we know dy dt is 4. Minus 4 times 2. And we know dy dt is 4. Minus 4 times negative 2, and we don't know dx dt. Okay, I'm going to simplify first, and then I'll combine like terms. So this is 8 dx dt minus 48 minus 32 plus 8 dx dt. So I end up with 16 dx dt equals, what is that, 80? Let's clean up my equal sign there. Oh, that's great. And I divide by 16 and I get 5. So the value of dx dt at time t equals 1 is 5. And we got it. Oops, that was a terrible highlighter. Let's try this again. There we go. dx dt equals 5 at t equals 1, which is what we were asked to find. Right here. So we did it. All right. I'm giving a self-high five to myself right now. Okay, so this question had some implicit differentiation, related rates. We had to interpret a vertical tangent line, so lots of stuff going on, especially from our first half of the course with derivatives. But this one's very doable. So anyway, good luck with these, and let me know if you need anything. Take care.